So we're going to talk about the behavior of loans and specifically how it closely ties to payout annuities. So something we've already covered. So the types of loans that we're going to look at are like auto loans or home mortgages, where typically a bank loans you an amount of money so that you can purchase your home, purchase your car, and then the idea is that you pay them back. Now, when they give you this loan, there's an interest rate. So say if we're buying a car that's $15,000, the bank will loan us the $15,000, but then it's like for the convenience of being able to use that money right away, we're paying them interest on that $15,000. The amount that we pay them goes beyond the $15,000 for that nice thing they did for us of giving us all that money so we could walk out with a car. So the behavior of this is the same as a payout annuity, which can be hard to understand at first. So here's a nice comparison. So in terms of a payout annuity, let's say that we had $10,000 invested at a bank and we're starting to take withdrawals. So the idea is that we're starting with $10,000 and then we're going to start taking money out of that. Let's say monthly. So as we start taking money out of that, that $10,000 is decreasing, but at the same time, it's increasing with some interest too. So like we talked about with retirement, we build up a certain amount for retirement, but then we also get the benefit of having some money being earned from interest that kind of extends that retirement amount that we have. So let's say we take those monthly payments out and then after 5 years, we have this balance of zero. So like the idea of using up our retirement, we don't have anything left. Now, in terms of a loan, let's say we borrow $10,000. So what they would do is they would have this account that has $10,000 in it. And what we need to do is pay it back to the bank. So instead of it being monthly withdrawals, it becomes monthly payments. So we're making payments on this amount, but the idea is that that amount, that $10,000, is decreasing. That amount that was loaned is decreasing as we're paying it off. However, at the same time, there's interest that is making that account grow because we have to pay back more than just the $10,000. So the behavior is the same. It's just instead of withdrawals to make it decrease, we're making payments to make it decrease. But same idea of starting with this amount of money, decreasing it, where it's also slightly increasing due to interest. So the behavior ends up working the same. So in terms of our formula, we just use the same formula for payout annuities. You might see slightly different notation, but I'm just going to stick to the same notation as our payout annuity for simplicity. But the idea is that A is the amount of the loan. So amount of the loan is what A will represent. And then D, where it was withdrawal amount, now that's going to be payment amount. Okay, so let's look at some examples here. So if you can afford a $150 per month car payment for 5 years, what car price should you shop for if the loan interest is 6%? So what we have here is we know what types of payments we could make. So D is going to be $150 for those $150 payments we can make, and then it's per month, so N equals 12. And then we're going to do that for 5 years. So T equals 5. And then the interest rate is 6%. And we want to find what A is. What's the loan that we should take out for this? So A equals 150, parentheses 1 minus 1 plus 0.06 over 12 to the negative 12 times 5, all over 0.06 divided by 12. And then we just plug that into the calculator. So division, 150 times 1 minus 1 plus 0.06 over 12 and all of that to the negative 12 times 5, all over 0.06 divided by 12. So 7,758.83. So we should be looking at cars priced around $7,758.83 if we have the 6% interest and we know we can make payments of $150 per month for 5 years. That's what we can afford. All right, let's say if you want to purchase a car for $15,000 and you have been approved for a loan at 4% interest for 5 years, what will the monthly payment be? So with this one, we don't know what D is. So that's our unknown. So we know the amount of the loan that we would want to take. We would want to take that $15,000 so we could pay for that car. We'll have a rate of 4%, and then we'll have that for 5 years. And we're making monthly payments, so N equals 12. So 15,000 equals D times, and we're going to have this big fraction of 1 minus 1 plus 0.04 over 12 to the negative 12 times 5 over 0.04 over 12. And we're going to have some steps here because we need to solve for D. So 15,000 equals D times. I'm going to plug in that whole fraction into the calculator. So we'll have a fraction of 1 minus 1 plus 0.04 over 12 to the negative 12 times 5 over 0.04 divided by 12. So that's 54.2991. But to keep that accurate, I'm going to use the calculator. So solving for D, I'm going to have 15,000 divided by that last answer in my calculator. So 15,000 divided by that last answer. So 276.25. So that would be our monthly payment. If we want to buy a $15,000 car, we have this interest of 4%. And then for 5 years. So if you've ever gone into a car dealership to buy a car, I don't know, I just know from my experience, they give you this spreadsheet of like the different percent loans that are, or sorry, the percent interest that's available through different banks, and then different lengths of the loan. So like 3 years, 5 years, 6 years. And with that, then you can see your monthly payment. So if you have an idea of how much you can put towards a car each month, then you can get an idea of what's the best length of time, what's the best percentage rate you want to go for, and then if you can't meet those monthly payments, then maybe it's time to look for a cheaper car or something like that. All right, last one here. I wanted to do an example with a credit card because a credit card is the idea of a loan. You're typically paying interest on your credit card. You have those monthly interest payments. So we have Lisa bought $3,000 of new furniture on credit. Because her credit score is not very good, the store is charging her a high interest rate of 16%. If she agreed to pay off the furniture over 2 years, how much will she have to pay each month? So the amount of that loan or that credit card charge is $3,000. They're adding 16%, so R equals 0.16. And then we're doing this over 2 years. And we're going to have monthly payments, so N equals 12. So 3,000 equals D times, and then we'll have 1 minus 1 plus 0.16 over 12 to the negative 12 times 2 over 0.16 over 12. So again, since we're solving for D, we'll have kind of 2 steps here. So let's go ahead and try to move this over here. All right, 1 minus 1 plus 0.16 over 12 to the negative 12 times 2 all over 0.16 over 12. So she's going to have monthly payments of 20, or sorry, that's wrong. That's a value that's multiplying with D. Ooh, good thing I caught that. So 20.42 about. I'll use the accuracy in the calculator. So I'm doing 3,000 divided by that last answer. So $146.89. So those would be the monthly payments to pay off $3,000 on the credit card if there's this 16% interest and you want to do it over 2 years. I just kind of want to see, I'm just kind of curious about that effect of that high interest rate. So the idea is making these payments of $146.89 for monthly for 2 years. So it's like 24 payments. So I just want to take that answer and multiply it by 24 to see how much money is she actually paying to her credit card company or this furniture store. So she's actually paying $3,525.34 for this furniture. So that's like an extra $500 just for the benefit of using the credit card and then having this kind of brutal credit score making this high interest rate. So you could do this comparison of how much is actually being paid. Like in those questions that we did with Payout Annuity, you can see how much is coming from interest. So in terms of a loan, there's this $525.34 interest that we have to pay in addition to those, to that $3,000 that was initially loaned.